Hello everyone, this is Amit Bhardwaj and today we are going to discuss a very important topic from thermodynamics, right? And this is Hess Law. So every year one question is coming from this topic. So very important, let us see. First of all, let us understand the concept, what is Hess Law, and then we will try to understand how to solve its questions, fine? So Hess Law. Before this, you should understand what is the meaning of state function. Okay, so state function is a function value of which will depend on the initial state and the final state, right? Its value will not depend how you are reaching to that state. Means it is independent from the path. So state function depends on the state in which our system is present, right? There are many state functions. So first of all, let us see, if I am talking about enthalpy, okay, what is H? H is enthalpy and enthalpy is a state function, right? That's why if I say change delta H, enthalpy change will depend only on the initial state from where we are starting and the final state where we are ending. It will not depend on the path which I am taking from to go from state 1 to state 2. Clear? So that's why you can say delta H value is independent from the path, right? So if I am going from point A to B, this is point A, this is point B, right? I am going from point A to B, I can go from this path. Imagine in this case enthalpy change is what? Delta H1, right? I am going from this path, I am going from A to B using this path. Imagine in this case delta H is delta H2 and in this path imagine enthalpy changes delta H3. As initial state and final state is same, right? So we can say that delta H1 is equals to delta H2 is equals to what? Delta H3. Because it is independent from the path. Clear? First point. Okay. Second thing, if I am going from A to B, imagine this one. I am going from A to B here. I am going A to B directly. Okay. So this is the delta H dash I am saying. For this process, when I am going from A to B, or I can say I am converting my reactant A into B, the enthalpy changes delta H dash, right? Or I can take some other path. Imagine first I am going from A to C, right? And then I am going from C to D and then I am going from D to B, right? So in this path you see, for this first step enthalpy changes delta H1, for this step enthalpy changes delta H2 and for this step enthalpy changes delta H3. Clear? So if I am going from this path, enthalpy changes delta H dash. But if I am taking this path, so what is enthalpy? You see, step by step, step 1 enthalpy plus step 2 enthalpy plus step 3 enthalpy, right? So I can say from here, from the next second path, enthalpy changes delta H1 plus delta H2 plus delta H3, right? It is the enthalpy change from path 2. It is the enthalpy change from path 1. So I can say both are equal, right? So it will help us. So you can see using 2-3 different equations, I can find the enthalpy change of an equation. What type of questions they will give? They will give us 3 equations, right? 2 equations, 3 equations, 4 equations depending on the question. Using those 2-3 equations, we have to find the delta H of given equation. So it is the most important question of Hess law, right? So you can see here what they are trying to say, same thing. What they are saying it states that total amount of heat evolved or absorbed in the reaction is the same whether the reaction takes place in one step or in number of steps, right? Clear? Same thing. And like in one step or number of steps, enthalpy change is what? Same. Clear? Next thing they are saying, the total amount of heat change in the reaction depends only on the what? Nature of initial and final. What is our initial thing and what is our final thing? Clear बच्चे? And next thing they are saying what? Independent from the path. So this is it about Hess law. Clear? So now let us understand. Let us go in deep with the help of questions. Fine? How to use Hess law. Same things we will use. Before starting this concept, let us understand one more small thing. Enthalpy change is, I will say it is extensive property. Okay? If I will change the amount of reactants and products, so definitely enthalpy of reaction will change. For example, if I am saying, imagine I am going from A to B, and for this enthalpy change I am saying X kilojoule, right? Here 1 mole of A is converting into 1 mole of B. If they will write this reaction, I am saying Na is converting to Nb. As enthalpy change is a extensive property, so its value will depend if you change the moles. Its value will change if you change the moles, right? So what will happen here? It become Nx. If I will divide my equation like 1 by Na, 1 by Nb, right? So you will see delta H will be what? 1 by Nx. And I am able to do this thing because enthalpy is what? Extensive property. That's why the delta H is depending on the number of moles, right? How much moles we are taking. And one last thing, if I flip the reaction, means I am reversing the reaction. Now I am going from B to A. In A to B, enthalpy change was what? X. So in B to A, definitely enthalpy change is what? Minus X. Clear? I am saying once again this point, you will see here, if I multiply equation by N, so it is what? Nx. If I divide my equation by N, so I will divide by what? X. I will divide by N. Or I can say I am multiplying my equation by 1 by N. So I am multiplying my delta H by 1 by N. Clear, bacha, right? And in this case I am flipping, so it will get negative sign. Imagine if forward A to B is endo, so B to A is what? Exo. It will change the sign. Endo become exo and exo become endo, right? So we will use these points in solving our questions. Okay, right? The first question they are saying here, they have given this reaction, right? M plus half O2 is giving MO. Clear? So for this they are giving MO plus this heat. So I can say the delta H for this reaction is minus of 351.41, right? As heat is added with the product, so it is exo reaction, right? Next thing I am saying delta H2. What is delta H2? Minus of 90.8 kilojoule, right? So now using these two equations, we have to find delta H for third equation. Okay? So we have to take care about 3 points when we are solving these questions, right? What are the points? What we need, how much we need, and on which side we need. I'm saying once again 3 points. What we need in our final equation, how much we need in our final equation, and on which side, means it is left side or right side. Let us understand what I am saying here. I want delta H of this reaction. Imagine I am saying I am finding delta H3. Clear? What we will do? In our reaction, what is present? M is present. Find where M is there, beta. M is present in which equation? M is present in our first equation. How much M is there? I need 1 mole of M. Here how much M? 1 mole M. First equation I have 1 mole M. The first equation will give me M. 1 mole, left side. So our equation is already ready to use. No need to multiply by something. No need to flip something, right? The first equation I will use as it is. I will say delta H1 as it is, right? Next thing I want to get XO. Where is XO? Second equation I have XO, right? But you see, XO in our reaction is left side, but in this reaction XO is where? Right side. So I need to flip it. And if you will flip the reaction, then I will use minus of delta H. Okay, so delta H1 and what is coming? Minus of delta H2. So I can say from here, what is coming? Delta H3. Delta H3 is coming delta H1 minus of delta H2. Clear? Now you can see the value, beta. What is delta H1 value? Minus of 351.41. minus of what? 90.8. Clear? Done. It will come plus, so minus 351 plus 90.8 something, right? Will come how much? Minus of 260 point something, 260.6 kilojoule. Okay? Done? Now, next question. So basically, using these given two equations, I have to make my third equation. Don't worry about, sir, how MO will come, X will come. MO and X will come by itself. Okay? Because of M, you use the first equation. Because of XO, you used which equation? Second equation. Both equations used, na? It's enough. Other things will be balanced by itself. Because you used both the equations. Fine? Next thing what we see. Now, again, they have given us two equations. Here, delta H1, they are saying minus 26.8 and delta H2 given as minus of 16.5. Using this, I have to solve this equation, right? What I need in my equation, I need Fe2O3. Where is Fe2O3? Fe2O3 is present in which equation, beta? First equation. I need 1 mole Fe2O3. Here already 1 mole present. Left, I need left side. Here also where? Left side. So it is already available. So delta H1 I will use as it is, without any flipping, without any multiplication, right? Now I need CO. I need CO. Now a very important point. When CO, I am talking about CO, right? CO is present. You see, I need CO, but CO is present in both the equations. CO is present in both the equations, right? So I will leave this CO. I should move forward. If any component is present in 2-3 reactions, leave that. Move to next one. Next beta which one? FeO, right? Now I want FeO. Where is FeO? FeO is present in second equation, right? Now I need 2 FeO, but here is only how much FeO? 1 FeO. So I need to multiply by 2. So 2 delta H2. Because I need 2 FeO, here how many beta? 1. So I will multiply by 2. Second thing, I need product side, right side, but here it is which side? Left side. So I will flip it. So flipping will give which sign? Minus sign, right? So delta H3 beta, if I am saying delta H3 is coming how much? Delta H1 minus of what? 2 delta H2. Okay, very easy. So what we are learning here, new point, if like I am moving step by step, but if some component is present in both equations or more than one equation, then don't use it. Go to next point, okay, to save time, to make the question easy, okay. So delta H1 value, if I say, what is delta H1 value? Delta H1 value is minus of 26.8 minus of 2 delta S2. What is delta S2 here? Delta S2 how much? Minus of 16.5. Clear? If you multiply here, almost plus will come, and you will see 16 to 33, and here 26.8. So 33 and 26.8, right? So yes, plus value is larger, na? So this value will get which one? 6.2, plus of 6.2, right? Clear? Next question. Next question is this one. Again, they have given us two equations, and now they are asking for the third equation. They are asking enthalpy of formation of carbon monoxide. Here they have not given us reaction. We have to make our equation by ourselves, right? Delta H formation of carbon monoxide, right? I am making my carbon monoxide. How many moles I will make, beta? 1. Okay, enthalpy of formation means I will make 1 mole of compound from its simplest constituent, right? C half O2. I will take its 1 mole. Be careful. I want to find this delta S3 using these above two equations, right? Again, what I need carbon. For my equation, I need carbon. Where is carbon? First equation have carbon. 1 mole, 1 mole. Left side, ready to use. I will say delta H1. Clear? O2. O2 is present here also, here also. As I said, if some like a reactant is present or product is present in both the reactions, leave it. Move to next one. I need CO. Where is CO? CO is present where? In second equation, right? But be careful. I need only one more CO, but hey, they have given two more, right? So divide it. Delta H2 divided by 2. I need right side. Where they have given? Left side. I will flip it. So because of flipping, what comes beta? Minus. Okay. So overall, if I am saying what is coming, delta H3 is coming delta H1 minus of what? Delta H2 divided by 2. Values are given to us. Delta H, they are saying minus X. Minus of delta S2 value is how much? Minus of Y divided by 2. If you solve this thing, so y is plus, minus plus. So it will go here, it is coming y minus of 2x divided by 2. Clear? Right? So what is coming? Y minus 2x divided by 2. Right? Again that point. Like O2 is present in both equations, so leave it. Move to next one. So because of carbon, I used my first equation. Because of CO, I used my second equation, right? Both equations used. So this O2 will be balanced by itself. Okay, right? Next thing. Now, again, simple question. We have to understand little bit here. Some extra point, okay? Understand. It's a good question. I need B. For this section, I am finding delta H. What I need? I need B, right? B is present in this section as well as in this section. We are using our trick, right? B is present in this section as well as in this section. So I will not use B. Okay? With the help of B, I will not take the equation. Leave B, okay? Leave B first of all. D is present in two equations, leave it. Come to E. Where is E beta? E is present in which equation? Only third equation. E is present only in third equation. E is present here, right side. Here, left side. So flipping is required here. So I will take minus of delta H3. I am calling this delta H3, okay, given value. Minus delta H3. C. Where C is present? C is present only in second equation. C is present only in second equation, right? So you see carefully. C is where? Here only. 2 mole I need. It is having 2 mole. This equation have 2 mole. As it is ready. So use it as it is. Delta S2. Delta S2 as it is. Right? I need 2C. 2C are present here. I am leaving those things which are present in 2 or more equations. I am searching for those things first of all which are present in only in one equation. Using E, I used my third equation. To get C, I use my which equation? Second equation, right? But by going this method, most of your 99% question will solve. But like in this question, our one equation is left. It is not possible that if they gave 3 equations but you use only 2 equations. No, you have to use third equation. Means little extra effort we have to put here, right? So think carefully. Now think carefully. When I am using delta H2, if you see, or I am using this equation, right? E plus A 2D minus delta H3, right? I am flipping it. So this will give us what? This will give us A, na? This will give us A, right? But you see here, I am flipping this, so this A will go where? Product side. But in my final equation, there is no A. In my final equation, there is no A. So I have to cancel this A with the help of which A? First equation's A. When some equation left, so we have to put some extra effort, some extra mind we have to use here, right? When I flip this, A will come on the product side, right? So I had to cancel this A using this equation. Here I have only half A, so I had to multiply it 2 delta H1. So that 2 will give us what? A. This A is reactant side and this A is where? Product side because of flipping. So this A will cancel this A. So in this way we used our third equation also, right? So we can say our delta H3 or I will say delta H4 is how much? 2 delta H1 I will say, plus of delta H2 and minus of what? Delta H3, right? Clear? Now you can put the values better. I will say it is what? 2 into delta H1. What is delta H1? 150. Plus delta H2, what is coming? Minus of 125. And minus of what? Minus delta H3. So its value is 350. Clear? What do you think? Clear? Okay, fine. So you can solve from here and you can get your answer. So if you solve this thing, it is coming how much? 300 from here, 50, and minus of 175 will come almost, right? Right, we are having B equation. Fine. So this is a little good question. We have to put extra effort here. Now, next thing, we have to understand one concept. Before doing other questions, we have to understand one small concept. Very, very important. Shortcut of Hess Law, you can say. We are having this equation and they are saying find delta H of this reaction. Clear? Now instead of giving 2-3 reactions, they have given us delta H. Imagine, first case I am taking. They have given us delta H formation of A. They have given us delta H formation of B. They have given us delta H formation of C. And they have given delta H formation of D. So for every component, they have given enthalpy of formation. So you can do two things. First of all, you write 4 equations according to given data. Using those 4 equations, you will find delta H for above equation, right? So it will take a lot of time, like we did in last questions. But we can solve this question in short way. In such questions, you can directly go, if you want to find delta H of this equation, and for every component, they have given enthalpy of formation, right? So you can apply that summation of enthalpy of formation of products, right? Minus apply summation of enthalpy of formation of reactants, right? So whatever is the enthalpy of formation of product is there, minus what is the enthalpy of formation of reactants. Okay, we will see questions. First, let us just remember the formula, right? Second thing, imagine for the above equation, they have given us enthalpy of combustion of A. They have given us enthalpy of combustion of B. And they have given us enthalpy of combustion of C and enthalpy of combustion of D. Don't forget that these enthalpies will be given for 1 mole. Like in this equation, A, B, C, D moles are given as small a, small b. So we have to be careful. Okay, these will be given for per mole, right? Now for every component, imagine for every component they have given enthalpy of combustion. So how you can find delta H of reaction? For every component they have given enthalpy of combustion, right? So I will say here summation of enthalpy of combustion of reactants. Be careful here, it is enthalpy of combustion of reactants. Summation minus of summation here, enthalpy of combustion of products. Be careful, in this case it is reactant minus product. It is Hess law. By these 4 enthalpies, I will write 4 equations, and then using the 4 equations, I will find enthalpy of which reaction? 5th reaction, the upper one, right? You will use Hess law, no doubt. By using 4 equations, you will find delta H for which one? 5th equation. But you can go in short way. It will give you direct result. It is Hess law only, nothing else, right? Now, next thing if I say, imagine for every component now, for every component, imagine they have given bond enthalpy. They have given bond enthalpy of every bond present in the reaction. They have given bond enthalpy. Bond enthalpy is the energy required to break one particular type of bond. Or I will say energy required to break 1 mole of a particular type of bond, right? So, if they have given bond enthalpy of every bond present in the reactants and products. So how you can find delta H of this reaction? Third shortcut formula, you can apply summation bond enthalpy of all those bonds which are present in reactant side minus sum of all those bond enthalpies for all those bonds which are where in product side. Okay, so depending on the data you have to use these three shortcuts. If they give formation of every component, use this. If they give combustion of every component, use this. And if they give bond enthalpy of every component, use this third formula, right? It will help to reduce like time to solve the questions. Clear? Let us see some question on this basis. Okay, fine. Now we can see beta what they are saying. They are saying we have to find enthalpy of this equation, right? SO2 half O2 SO3, and they have given the value of heat of formation. See carefully, they have given value of heat of formation of SO2 and SO3 both given. For the reaction components, they have given enthalpy of formation, right? For O2, the enthalpy of formation is what? 0. For SO2, enthalpy of formation given. For O2, to beta, enthalpy of formation is 0. Why? Because it is already standard state. If an element or its molecule is present already in its standard state, so its enthalpy of formation taken as what? 0, right? How you will make O2? O2 is already what? Standard state of oxygen. SO3, delta HF is given. So for all the components of the reaction, enthalpy of formation is given to us. So we'll apply that first formula we did in last page. Enthalpy of reaction, we can find, what is that? Enthalpy of formation of products minus of enthalpy of formation of reactant, right? So for product, SO3 beta, for SO3 what is enthalpy of formation? Minus 98. 1 mole of SO3 in the reaction and its enthalpy is 98.2, right? Minus, for reactant now, 1 mole SO2, and for SO2 how much is given? Minus 2, 98.2, okay? Plus half mole of O2, but for O2 though enthalpy of formation is what? 0, right? So if you are saying here minus 98 and what comes? Plus 298, right? So if you solve from here, plus minus, so almost 200 coming, right? So we can say here 200, right? Now next one you can see. Sorry. Okay, right? Now in this question, they are asking delta H for this given reaction. They are asking delta H for this given reaction, and what they have given? They have given enthalpy of formation of H2O2 as well as what? H2O. So they have given its enthalpy of formation. H2O2, they have given enthalpy of formation of H2O, and you know very well enthalpy of formation of O2, sorry I will say, enthalpy of formation of O2 is what? 0, right? Again same formula we will apply. What is that? Enthalpy of reaction is what? Enthalpy of formation of reactants. So 2, because I am making 2 moles, right? 2, what is the H2O liquid enthalpy of formation? Minus of 286 only, right? And O2, 1 mole, for this it is 0, minus for reactant, 2 mole of reactant here. So what is the value given? 2 into minus of 188, right? So we can solve this, right? 2 into minus of 286, 2 into minus of 188, right? This will become plus, this is minus, so if you solve, so almost will come here, minus of 196, right? Because negative value is larger and positive value is smaller, so negative answer will come, right? This one, if you solve this thing, clear? Good. Right, next thing is, now they are asking delta H for this reaction, right? And what they have given us bond enthalpy of HH bond, bond enthalpy of Br bond, and bond enthalpy of what? HBr bond. third type. If for the reactant and products they have given the bond enthalpies. So bond enthalpy of reactants minus bond enthalpy of product. Don't forget about it. Bond enthalpy of reactant minus bond enthalpy of product, right? So if you look better here, so what is coming? If I go delta H of reaction, bond enthalpy of reactants. First understand, 1 mole of H2 na? 1 mole H2 means it have 1 mole of HH bond. 1 mole Br2 means it have 1 mole of Br bond. 2 mole HBr means it is having 2 mole of HBr bond, right? First of all, count the bonds. 1 mole HH bond, 1 mole Br bond, and 2 moles of HBr bond, right? Now, reactant minus product. 1 mole of HH bond, what is value of this? They have given 433 plus 1 mole of Br bond, so 1 into 192, clear? And minus bond enthalpy product, 2 moles, right? 2 mole of HBr bond, so 2 into 364, right? If you solve from here, you can solve this and you'll get the answer, right? Clear? Easy again. So again I am saying bond enthalpy of reactants minus what? Bond enthalpy of product. Next one. Again same question they have given based on same concept. For this reaction, for every component, reactant as well as product, they have given bond enthalpy. Bond enthalpy of N triple bond N, H bond, N H bond, right? If I write the reaction, N triple bond N plus, we have 3 moles of HH bond, right? Because 3H2 is there, na? And here we have 1 mole ammonia have 3 mole of NH bond. So 2 mole of ammonia will have 6 mole of what? NH bonds, okay? Reactant side include 1 mole of N triple bond N, 3 moles of H bond, and here product side have 6 moles of NH bonds, right? So we can go for delta H of reaction, right? So N2, 1 mole of N2, right? What is N2 energy they are given? 945 plus 3 moles of HH bond, 436. So it is the bond enthalpy of reactants minus bond enthalpy of product. What is product here? Ammonia have NH bonds, right? So 6 moles. 6 moles given here. 6 into what? 391. Okay? You can solve these things very easily, right? What is the point? Bond enthalpy of reactants minus bond enthalpy of product. You can solve this and you will get answer easily. I think you will get minus 93 from here. Okay, done? Now, next thing is, okay, enthalpy of hydrogenation of cyclohexene is given. Now, we are introducing some other type of enthalpies here. Enthalpy of hydrogenation we are using here, and we are using resonance energy. Major part we have done. Now small questions on other enthalpies as well, right? So enthalpy of hydrogenation of cyclohexene is minus 119.5. That means they are saying if I will convert 1 mole of hexene, as it have 1 pi bond, so I will add 1 H2. I am converting 1 more cyclohexane into cyclohexane, and for this delta is given as minus of 119.5. This is given. Fine. Now they are asking, and they have given resonance energy of benzene is given minus 150. Fine. Enthalpy of hydrogenation of benzene they are asking. First let us understand. Benzene have 3 pi bonds, right? Clear? Is it actual benzene? No. Benzene is this one, beta. This is actual benzene, na? It is the hypothetical resonating structure. It is our RH, resonance hybrid. It is our RS, resonating structure, right? First of all, understand when you will go from here to here, how much delta H will come? RH to RS. RH have lower energy, RS have higher energy. So here you will take positive of what? Resonance energy. Resonance energy is the energy difference between the most stable resonating structure and the resonance hybrid. We have to use it accordingly. If I am going from RH to RS, so I will take positive. If I go from RS to RH, I will take a negative. So here resonance energy is given. Value we have to use 150.4. So this value here I am saying this is delta H1 is how much? 150.4, right? Because I am going from RH to RS. Don't confuse why I am taking here plus sign, not minus, because I am going from RH to RS, right? Now here I am breaking 3 bonds of this. I am breaking 3 pi bonds by adding 3 H2. Like I am doing here, I am breaking 1 pi bond. I am breaking here 3 pi bond, and I will make it what? Cyclohexane. So definitely here, this delta H2 is 3 times of above, right? So it is 3 times of minus of 119.5. So what is delta H coming finally for overall process? This complete thing is hydrogenation of hydrogenation of benzene. So delta H is what? Delta H1 plus delta H2. Fine. What is delta H1? Delta H1 is 150.4 plus, and delta H2 what? 3 into minus of 119.5. Okay. So from here almost minus 360. From here almost what? Plus of 150. So if you solve this thing, definitely minus something like minus 20 should come. Clear? You can solve this. But be careful. This is benzene. This is hypothetical resonating structure. Okay. Right. Good. Fine. Now, one last question we will see. What do we have here? We are using here heat of atomization. Okay. What is the atomization? Let us understand. Heat of atomization means they will give you some compound. It can be liquid, solid, gas, whatever. It depends what they are giving in the question. And you have to convert that compound into its atoms, gaseous atoms, where there is no bond present. They give me some compound, I have to convert it into individual atoms. In which state? Gaseous state, right? So what they have given to us? Understand? Atomization of pH3 they have given. So I am converting pH3 gas into P gas here, and here 3 hydrogen. I am not writing H2 because I have to keep every atom separate, right? Every atom separate. For this they have given the delta H value as pH3, na? So 954. They have given us what? 954. Fine. So if you understand carefully what is happening here, it is already gas. So I am having here pH3. We know it's phosphine. I am converting this into this by breaking 3 pH bonds. I am breaking 3 phosphorus hydrogen bonds. So I can say 3 into bond enthalpy of pH bond is coming equals to what? 954. From here I can say bond enthalpy of one of the pH bond is how much? 954 divided by 3. So from first reaction I am finding the bond enthalpy of pH, right? Now we have to take P2H4. We are having here P2H4. Okay, you will see here in P2H4 we will have this structure. This is P2H4, and I am converting this into what? 2 of phosphorus gas here and 4 of hydrogen gas here, right? And for this reaction they have given us delta H value. What is the delta H value, beta? They have given delta H value 1485. It's 1485. Fine, right? So be careful. It is gas. So I am just, what I am doing here in this reaction, I am just breaking the bond. Which bond? One of PP bond and remaining what? pH bonds. So I can say this delta H, that is 1485 is actually what? It is bond enthalpy of PP bond plus it is what? It is 4 into bond enthalpy of the which bond? pH bond. This value we got from here, right? So we can find from here the bond enthalpy of PP bond will come how much? Will come 1485, right? Minus of what? 4. 4 into how much here given? 954 by 3. Right, clear? So this way you can get the value. There are many type of enthalpies, but the basic rule of Hess law is our initial questions, where by they will give 2-3 questions, they will give 2-3 equations, and using those 2-3 equations we have to find delta H for the fourth equation. Okay, clear? And how and why we can do this? Because delta H is a path function. H is a path function. I will say, delta H which function? Is a state function, right? It will not depend on the path, right? So that's why using 2-3 equations we can find delta H for which equation? Final equation, right? So I think this will help you. Okay, thank you very much. See you in the next lecture. Bye.